Hi. This time we have to remove any elements from a given list that are not in a non-decreasing sequence from the beginning of the list. So at the end we have something that's sorted but potentially shorter than the input. And here's some test data that we're given. And there are a couple of different ways we can do this. Let's look at a very literal interpretation of the problem statement. So here's an anonymous lambda, and we want to compare adjacent elements to see if they fit. So we can do that with the 2y's or pairwise less than or equal to over the argument. What this means is that 1 is less than 3 and 3 is less than 7, but 7 is not less than 3. So the first element we always want to keep, of course, and then because that's where the sequence begins, and then uh, this one we want to so this one we want to keep, this one we want to keep, this one we want to keep, this one we want to remove because it's out of sequence. 5 is greater than 3, but it's not being eliminated by the first pass. So let's put in a 1 here to keep the first element, and then we take the argument and filter it by this mask. Yeah, there we go. So here the 5 is there, the 8 is there, and that means that we really have to apply this again. So if we use the power operator to apply this twice, then we can see that we have eliminated the 5. However, since we have the two 4s over here at the end, they still survive, so we need to do it again. Okay, this is good. If we keep doing it, then nothing more happens. And then there's a trick that we can specify a match instead of a number, and that means we'll keep doing this until there are no more differences. So until the two consecutive iterations match each other. We can give this a name, and we can do ft, and that solves the problem. However, it's not a very efficient way of doing it because we are doing a multipass on this. So instead, what we can do is a single pass, and the way we can do it is by scanning using maximum. So this gives us the largest value that we have seen so far. Okay, we can still see T up here. You can see we never go down again. Now we just need to keep the elements that are either already, well, we need to keep the elements that match the current maximum, because if they don't match the current maximum, then they must be smaller than the number we've already seen and they need to be eliminated. So equal to the maximum, this gives us the corresponding elements, and then we just do the filtering like we did with the first method. So here's a single pass solution for the elimination sort. Thank you for watching.